Selamat sejahtera to Dr. Azam and my fellow friends. I'm Chong Ming 298408 and I will be explaining the solutions for question A. So as we can see that we are given a general market model as shown on the slide. The first part of the question requires us to describe the relationship between any two goods in a model and justify why so. To determine the relationship between any two goods in a model, we can compare the demand function of the goods, which are functions 1, 3, and or 5. Now we will be comparing functions 1 and 3 to determine the relationship between goods 1 and 2. By comparing the functions, we can see that variable P2 does not exist in 1 and variable P1 does not exist in 3. This means that the change in price of one good does not affect the quantity demanded for the other. Hence, we can conclude that goods 1 and 2 are independent. Now we would be doing the same for goods 2 and 3. By comparing functions 3 and 5, we can see that variable P3 does not exist in 3 and variable P2 does not exist in 5. This would mean that change in price of one good does not affect the quantity demanded for the other. Hence, we can conclude that goods 2 and 3 are independent. Next, we would be comparing functions 1 and 5 to determine the relationship between goods 1 and 3. By comparing the two functions, we can see that variable P3 exists in 1 and variable P1 exists in 5, and the parameter in both variables are positive. This means that the increase in price of one good would cause quantity demanded for another good to increase and vice versa. Hence, we can conclude that goods 1 and 3 are substitutes. In the second part of question A, we are required to derive a system of three simultaneous equations in the price variables using equilibrium conditions and then transform them into matrix form. To solve this, use equilibrium condition QDI equals QSI, then simplify the equation and rearrange the terms like this as shown in the example of good 1. Repeat the same process for goods 2 and 3. Now that the system of simultaneous equation is formed, we would express the system in matrix form AX equals B. And this is the matrix form of the system of simultaneous equation. This matrix is coefficient matrix A. This matrix at the middle with price variables is variable matrix X. And this matrix at the right hand side is constant matrix P. That is all for question A. Thank you.
Hi, dear Professor Azam and my fellow friends. My name is YING, matching number 299683. Today, I want to solve two questions B1 and B2. B1 is using the equilibrium conditions again, derive a system of three simultaneous equations in the price variables and transform them into the metric form. For B2 is using the Cramer's rule, solve for the equilibrium price. For question B1, we will discuss solving three equations in three variables by Cramer's rule. To derive the equilibrium conditions, we set the quantity demand equal to the quantity supply. So the first equation is 3P1 minus 5P2 minus 2P3 equal to 100. The second equation is 4P2 equal to 150. The third equation is 2P1 minus 4P3 plus 3P2 equal to negative 120. For solving Cramer's rule, 3 times 3 equations, consider an equation with 3 variables P1, P2, and P3. So the first equation is 3P1 minus 5P2 minus 2P3 equal to 100. The second equation is 4P2 equal to 150. The third equation is 2P1 minus 4P3 plus 3P2 equal to negative 120. First, we write the equation in the form AX equal to B. The first column of A is 3, 0, 2, second column is negative 5, 4, 3, and third column is negative 2, 0, negative 4. X is P1, P2, and P3. Then B is 100, 150, and negative 120. For question B2 is use the Cramer's rule, solve for the equilibrium price. As Cramer's rule, determinant value is important to find the value of variables. Here also we need to find A, A1, A2, and A3. So the answer of A is negative 32. Next, for A1, replace the first column of matrix A with values of B. The A1 is negative 6,460. For A2, replace the second column of matrix A with values of B. So the answer of A2 is negative 1,200. For A3, replace the third column of matrix A with the values of B. So the answer of A3 is negative 5,090. So here is the last step. Once we get the determinant values, put them in the formula. Formula of P1 is A1 over A. Formula of P2 is A2 over A. For formula P3 is A3 over A. So the answer for P1 is 201.88. P2 is 37.5. P3 is 159.06. So these are the steps to solve three equations in three variables using Cramer rules. Thank you.
Assalamualaikum and hi to Dr. Azam and also my fellow friends. My name is NURIZYAN binti SUFIAN and my metric number is 301241. I will be answering question D3, which is solving the equilibrium prices using the matrix inversion method. To find the simultaneous equation, we need to use the equilibrium condition, which is QD equal to QS. For example, for the first equation, after we arrange QD1 equal to QS1, we will get 3P1 minus 5P2 minus 2P3 equal to 100. Use the same step to get the second and third equation. For the second equation is 4P2 equal to 150, and the third equation is 2P1 plus 3P2 minus 4P3 equal to negative 120. Using all the three equations from the simultaneous equation, we need to change the equation into the metric form, which is AX equal to D. In the box of A, we will insert the value from the equation, which is 3, negative 5, negative 2, 0, 4, 0, 2, 3, and also negative 4. For the box of X, we need to insert P1, P2, and also P3. Last, for the D value, we need to add the constant value from the equation, that is 100, 150, and also negative 120. By using the matrix inversion method, we will use the element in the first row and multiply with its respective cofactor. That equals to 3, negative 5, and also negative 2. For example, to solve the respective cofactor, for cofactor A11 is 3. We need to multiply as the 2 by 3 matrix using the AD minus with BC, which is 4 times negative 4 minus with 0 times 3, and the answer will be multiplied with the cofactor A11, which is 3. After solving for the first row and all the third column, we will get the determinant of A that equals to negative 32. Next, we need to find the cofactor of matrix A and transpose. As the notes given, A to 1 mean the number 2 refer to the row and 1 refer to the column. Using matrix A, we need to derive 9 elements of the cofactor. For example, given for A11, A12, and also A13, we need to use some steps as the determinant to multiply, but we did not need to multiply with itself. For A11 equals to 4 times negative 4 minus with 0 times 3 equal to negative 16. A12 equals to 0 times negative 4 minus with 0 times 2 equal to 0. A13, 0 times 3 minus with 4 times 2 equal to negative A. And after solving for all 9 elements, we will get cofactor A equals to negative 16, 0, negative 8, 26, negative 8, 19, 8, 0, and also 12. After getting all the cofactor of A, we need to transpose the cofactor, which means to rearrange the place. After the transpose, negative 16, negative 8, and also 12 will stay the same, but for the other, we need to change the place and also the positive and negative symbol, which opposite as 0 with 26, negative 8 with 8, and 19 with 0. So the cofactor of A transpose is equal to negative 16, negative 26, 8, 0, negative 8, 0, negative 8, negative 19, and also 12. Last but not least, to solve, we need to substitute the determinant of A and also cofactor of A transpose into the formula. X equal to 1 over determinant A multiplied with cofactor of A transpose multiplied with D. After substitute into the formula, we need to solve one by one. Firstly, solve the cofactor of A transpose multiplied with D. For example, negative 16 times 100 plus negative 26 times 150 plus 8 times negative 120, and we will get negative 6460. After the same step, an example, for the second row, we will get negative 1200, and the third row equal to negative 5090. We need to multiply this value with 1 over determinant of A, which is 1 over negative 32. We will get the equilibrium prices value for P1 equal to 201.88, P2 equal to 37.5, and also P3 equal to 159.06. That's all for solving three goods for simultaneous equation using the matrix inversion method. Thank you.